Okay, so back with another video. Some of you guys said that you were struggling with number 14 on the homework, so I'm always more than happy to make a video. I also got some feedback from you guys that you prefer me to go through the problem like right on the spot. You wouldn't want me to like have the answers like pre-written. So that's exactly what I'm going to do. So let's look at the alternating series test because it has a lot of parts to it. So hopefully this example, this concrete example, will help you get a better sense of how exactly to use it and when exactly to use it. So this is pulled directly from the Paul's online notes, so hopefully you guys are looking at that as a resource. So suppose that we have a series, a sub n, and either it looks like this, a sub n looks like this, or a sub n looks like this. So -1 to the n times something, or -1 to the n plus 1 times something. An important thing to keep in mind is we have to make sure b sub n, the thing in this case, is greater than or equal to 0 for all n. Then, if the limit as n approaches infinity of b sub n is equal to 0 and b sub n is a decreasing sequence, then we can for sure say the series a sub n is convergent. Lots of moving parts. So let's look at this example right here, get a better sense of it. We have the sum from n is equal to 1 to infinity of -1 to the n plus 2 times 7n all over 3n minus 1. So it looks really similar. It definitely looks similar, but this is -1 to the n plus 2. And we want either -1 to the n or -1 to the n plus 1. So it doesn't look perfect. But maybe if we look back to, I don't know, 9th grade, when we learned our exponent rules, maybe we can rewrite this in a way that is beneficial to us. And that's going to be a recurring theme throughout series and sequences. Rewriting it in an equivalent form can reveal some underlying structure of the series. So maybe you guys remember a number to an exponent where it's like x plus y is equal to a to the x times a to the y. So the way we've split our sum, the thing, I guess, -1 to the n times -1 squared. -1 squared is 1. -1 times -1 is 1. So our series is equal to, n is equal to 1 to infinity of -1 to the n times 7n all over 3n minus 1. So we have officially checked this box. Okay, it looks like a sub n, the thing next to the series, looks like -1 to the n times b sub n. It matches up. Next step, we have to make sure b sub n is greater than or equal to 0 for all n. Okay, so remember b sub n in this case is all of this. It's the stuff next to the -1, I guess. So you can type this out to a calculator, or you can test out points. Maybe we can test out points to get a better sense. When n is equal to 1, this is equal to 7 over 2. When n is equal to 2, this is 14 over, what is that, 5? And why not, when n is equal to 3, this is 21 over, what is that, 9, 8. Okay, so it looks like no matter what value of n we plug into b sub n, this is going to be greater than or equal to 0 for all of them. Okay, so we've satisfied box number 2. Let's look at box number 3. Okay, so we decided that b sub n is equal to 7n all over 3n minus 1. Is the limit as n approaches infinity of 7n over 3n minus 1 equal to 0? Unfortunately, it's not. This is not true. is actually equal to 7 over 3. So because this limit as n approaches infinity is equal to 7 over 3 and not equal to 0, we do not satisfy this condition. And once you do not satisfy one of the conditions, we can't use the alternating series test. We can't say for a fact that the series, the sum base of n, is convergent. But as additional practice, let's check the final condition. Is b sub n a decreasing sequence? So b sub n, right, is just the terms. So like these terms. Is this a decreasing sequence? Okay, so oops. B sub n would be equal to like a set of numbers, like 7 over 2, 14 over 5, 21 over 8, on and on until it approaches like 7 over 3. Right? Is this a decreasing sequence? Looking at the numbers, maybe it's not obvious. I have Desmos right here, and you can kind of see, yeah, it's decreasing. So it satisfies the last condition. And even though we satisfied 3 out of the 4, the fact that we don't satisfy one of them means that we cannot use this test, and we don't know for sure, using this test, whether or not it's convergent. Maybe another test would work. But hopefully this helped you out with the homework. Let me know if you guys have any more questions.